So welcome. In this lecture we're going to talk about data structures. So in the course so far we've seen data types, and data types have been ways of modeling something we want to represent in a computer program. We began with early examples such as modeling a hand of cards, modeling an individual card and its components, a suit and a rank, and we built that up into a model of a whole hand of cards using a list-like data structure. We've also seen some other examples. So other examples of data types that we've looked at was the expression data type that we used to represent arithmetic expressions so that we could manipulate them, evaluate them, modify them, and so on. Today we're going to look at data structures. So data structures are not just about modeling something, but really it focuses more on the way that we model things, in particular the way that we store data. And the way that we choose to store data in general is very much dependent on what we want to do with it. And so data structures is the study of ways of storing data for a particular purpose that make it efficient, effective, fast to perform the operations on that data that are interesting. Now it's useful to understand data structures in a slightly different context, and that's the context that we're going to look at today, something called an abstract data type. So you can think of an abstract data type as being like a data type, but where we don't talk about how we represent the data concretely, but the kind of things that we want to do with the data. So it's typically described in terms of the operations that we want to perform on the data. And this is independent of the way that the data structure is used, which data structure we choose to implement the data type. So it separates the specification, the interface, the way we interact with the data, from the way the data is represented. So then in those terms, a data structure is a particular implementation of an abstract data type. And what's interesting about this way of seeing things is that it separates the use of the data type from the implementation. And in particular in the construction of software, it means that if a program is using a data type, it doesn't have to care too much about the way it's represented internally. And in fact, we can start off with a very simple representation, which maybe is not very fast or efficient. And we can improve it over time without having to change the program which uses that data type. Hopefully these things will become much clearer once we get into some examples. So what we're going to look at then today is two examples of abstract data types. Queues and lookup tables. And queues are corresponding to the intuitive concept of a queue. We're going to see a couple of different ways of implementing a queue, and we're going to also look at an efficient way of implementing a lookup table. We've seen one way of doing that using lists, and the list is not a terribly efficient way of representing a lookup table, and we'll look at a classical way of representing that in a more efficient way that allows us to look up things more quickly.